After studying this module, you shall be able to understand the concepts of utility, especially total utility and marginal utility. We would also discuss the law of diminishing marginal utility, the water diamond paradox, the concept of utility functions, the different types of utility functions, also the cardinal utility theory and the ordinal utility theory. Now I will give a brief introduction of this module to you. We mentioned in the module on law of demand that the economic model of consumer behavior is very simple and can be summarized in one sentence. That is, people choose the best things they can afford. Here in this chapter, we would talk about what do we mean by best things and affordability, and why do people choose the best things. For this, we will introduce the concept of utility and explore what role it plays in consumers' choices. The concept of utility is required to explain consumer behavior and preferences. The theory of consumer behavior has been formulated entirely in terms of consumer preferences, and utility is seen only as a way to describe preferences. It mainly studies and seeks to explain the reasons and the logic that underlie purchasing decisions and consumption patterns. It explains the processes through which a consumer makes decisions. We have already discussed in detail consumers' demand and its relation with prices and income. In this module, we will define utility, explain its measures, discuss the concept of utility functions and related concepts.
Utility in plain English means usefulness. Economists define utility as the benefits consumers obtain from the goods and services they consume. However, people may have different views on what is more useful and what is not. Moreover, the price we are willing to pay is not always linked to how useful a good is. For instance, a person may be ready to pay a lot more for a BMW car than for a Hyundai car, which may well be just as useful. Also, there are many questions we need to answer, like how are we supposed to quantify the amount of utility or benefits associated with different choices? Is one person's utility or benefit comparable to that of another's? Or how do the benefits derived from consumption of different quantities of the same good differ? To answer some of these questions, it becomes important to measure these benefits or derive a measure of utility. Economists have discussed various ways to use the indicator of utility to measure benefit derived by a person from consumption. Some have given a monetary measure, while others proposed ranking the benefits. Over time, economists have identified that all that matters about utility, as far as consumers' choice behavior is concerned, is whether one consumption bundle has a higher utility than another consumption bundle. In other words, preferences of a consumer determine their choices, and utility is a way of describing preferences. Let us now consider the concept of total utility, TU. Total utility, or TU, is the total amount of satisfaction or total benefit derived from consuming a given good or a specific bundle of goods and services in a particular period of time. In general, it is assumed that consumers find more is better. That is, larger the quantity consumed of a good, higher is the total utility. However, utility increases at a diminishing rate as consumers consume more and more of a good. This is demonstrated in the following example. 100 units of utility are derived from consuming one ice cream a day. Total utility may increase to 160 if another unit of ice cream is consumed. In case and if a third unit is consumed, then it results in total utility increasing to 200 units and so on. Note that in this example, the consumer derives maximum total utility by consuming 5 units of ice cream per day, and consumption of the sixth unit does not give any additional utility. This is the point of satiation for the consumer, as thereafter total utility actually declines if more than 6 units of ice cream are consumed in a day. For example, the consumer starts feeling sick from having so much ice cream in a day. This can be clearly explained with the help of a diagram. As more and more of a good is consumed in a given period, we expect that the total utility will increase at a decreasing rate. Hence, the shape of the curve observed in the top panel of figure 1. Total utility may eventually reach a maximum and it may even decline thereafter if far too much of the good has been consumed. The total utility changes with each unit consumed. This brings us to the concept of change in utility or additional utility or marginal utility. Now we will take up the concept of marginal utility. Marginal utility or MU is defined as the change in total utility, that is TU, that can be attributed to consumption of an additional unit of a good during a particular period of time. In the above example, the first unit of ice cream gives 100 units of utility, and when the consumer consumes the second unit, she gets 60 additional units of utility, so that marginal utility is 60. However, as she consumes the third unit, marginal utility diminishes as the additional utility from the third unit of the ice cream is only 40. From the calculations given in the table, it should be clear to you that marginal utility of the nth unit consumed, that is MUN, is calculated by taking the difference between TU attained by consuming n units of a good X, that is TUN, and TU attained by consuming n minus 1 units of X, that is TUN minus 1. Therefore, we can write TUN minus TUN minus 1 equal to delta TU equal to MUN. Essentially, marginal utility measures how does a consumer's utility changes as we give him or her a little more of a good. That is, it captures the rate of change in utility, denoted as delta U, associated with a small change in the amount of good, denoted as delta X. Hence, marginal utility can also be written as the following ratio, which is MUX equal to delta U upon delta X. It implies that to calculate the change in utility associated with a small change in consumption of good X, we can just multiply the change in consumption of X by the marginal utility of X. and get delta U equal to MUX into delta X. Diminishing marginal utility. We see the marginal utility is derived from total utility. As consumption of X increases, total utility increases, but at a decreasing rate. That is, the addition to utility is reducing as we consume additional units of X, and hence marginal utility declines as consumption of X increases. This is because as we consume more, the good becomes less desirable, with subsequent units giving lesser satisfaction at the margin than the previous unit consumed. This is called diminishing marginal utility. In the following example, we see that as consumer moves from first unit to second unit, the additional utility derived from second unit, which is 60, is less than what is derived from the first unit, which was 100, and it is consistently declining. Mu is equal to 60 for the third unit, and so on. It eventually becomes 0 when the sixth unit is consumed, and beyond this point of satiation, it turns negative after the seventh unit of the good is consumed. Another very basic example is water. Suppose you are extremely thirsty after returning home on a hot summer afternoon. The first glass of water you drink gives you immense satisfaction as it quenches your thirst. The second glass also gives you satisfaction with its cooling effect, but it is less valued than the first glass. Subsequently, the third and fourth glasses of water gives even less satisfaction or utility as your thirst is already quenched. This demonstrates that the marginal utility derived from consuming water will diminish. The above phenomena is called the law of diminishing marginal utility. The law of diminishing marginal utility states that the extra benefit or utility that a person derives with increase in consumption of a good, diminishes with each additional unit of the good consumed. Now we will discuss the diamond water paradox. The paradox, in Adam Smith's words, the things which have the greatest value in use have frequently little or no value in exchange. And on the contrary, those which have the greatest value in exchange have frequently little or no value in use. Nothing is more useful than water, but it will purchase scarce anything. Scarce anything can be had in exchange for it. A diamond, on the contrary, has scarce any value in use, but a very great quantity of other goods may frequently be had in exchange for it. Using the concept of marginal utility, the solution to the paradox is simple. The maximum amount a consumer is willing to pay for a given unit of a good depends on the marginal utility he derives from it. The consumer will be willing to pay the most for the first unit of ice cream consumed, and he would be willing to pay less for additional units consumed thereafter. Essentially, if diminishing marginal utility holds, then as a consumer purchases more of a good, the less is the marginal utility, and hence he will be willing to pay less for each extra or marginal unit. Also, willingness to pay depends, ceteris paribus, on the level of consumption, since the greater the amount consumed, lower is marginal utility. In case of water, W, it is so plentiful and relatively cheap that we use so much of it, and hence the utility derived from the final unit consumed is quite small, whereas diamonds D are scarce in relation to demand, and because we use them in small quantities as compared to water, the utility derived from the last unit and its price are very high. The total utility of all the water used by a consumer is far greater than the total utility from all the diamonds she buys. However, demand depends on marginal utility and not on total utility. Clearly, it is marginal utility, not total utility, that determines the consumer's willingness to pay price. Since we consume few diamonds, the marginal utility is high, and consumers are willing to pay a high price. This can be seen by looking at the marginal utility curves for water in Figure 2 and for diamonds in Figure 3 respectively. The magnitude of marginal utility depends on the magnitude of utility. Hence, the way we measure utility becomes important. This means that marginal utility itself has no behavioral substance, and we cannot calculate marginal utility from a consumer's choice behavior. Now we will discuss concept of utility functions. How well do economists measure utility? This is the question we would like to understand and answer. To measure utility, we need a function which enables us to assign a number to each consumption bundle so that we can compare the satisfaction derived from each consumption bundle. In simple words, utility function UF is a method of assigning a numeric value to each and every consumption bundle in a way that more preferred consumption bundle gets a higher value than a less preferred bundle. It is a function of all the goods consumed by a consumer. If there are two goods X and Y, then the utility function would be UF is equal to UF into XY. In general, individuals consume many goods and individuals' preferences are assumed to be represented by a utility function of the form UF, a function of x, y, z, etc. till Lm, where x, y, z, Lm are the quantities of each of n goods. They are x, y, z, Lm that might be consumed in a period. For simplification, we stick to two commodities, capital X and capital Y, or X and Y. So if there are two consumption bundles, small x1 and small y1, and x2 and y2, and x1 and y1 is preferred to x2, y2, then the numeric value of utility from x1, y1 is greater than the numeric value of the utility from x2, y2. That is, if x1, y1 is greater than x2, y2, then UF x1, y1 is greater than UF x2, y2. There are different types of utility functions. We discussed some of the important and commonly used utility functions, which are Cobb-Douglas utility function, quasi-linear utility function, perfect substitutes utility function, and perfect complements utility function. First is the Cobb-Douglas utility function. This function we write as UF given x and y is equal to x raised to power alpha into y raised to power beta, where alpha is greater than 0 and beta is greater than 0, and describe the preferences of the consumer. Alternatively, using monotonic logarithmic transformation, Cobb-Douglas utility function could also be represented as follows, which is log UF of xy equal to alpha log x plus beta log y, where alpha is greater than 0 and beta is greater than 0. The Cobb-Douglas utility function can be expressed in a variety of ways. We have to learn to identify its various forms, as this family of preferences is very widely used in consumer theory. Second type of utility function is the quasi-linear utility function, or some people also may pronounce it as quasi-linear utility function. A quasi-linear utility function has the following functional form, that is ufxy is equal to capital Fx plus y, where fx is some non-linear function of x, which is part 1. The function uf x, y is linear in y. In these functions, the utility function is linear in one good, but possibly non-linear in another. Hence the name quasi-linear utility, which means partly linear utility. Some specific examples of quasi-linear utility functions include a utility function ufxy is equal to ln x plus y, b utility function ufxy is equal to root x plus y. Note, quasi-linear utility functions often may not particularly be realistic, but are easy to work within theory. Third type of utility function is perfect substitutes utility function. If x and y are perfect substitutes, this means the consumer is interested in the total number of units of x and y he is consuming, as both x and y fulfill exactly the same purpose. All that matter to the consumer is the total number of both goods together. Thus, it is natural to measure utility by the total number of x and y. A perfect substitute has the following functional form, that is ufxy is equal to alpha x plus beta y. It is an additive utility function. For example, green pencils and blue pencils. Both can be used interchangeably. Hence, they perfectly substitute each other if available at the same price. Moreover, monotonic transformation of ufxy will also represent perfect substitutes. Fourth type of utility function is perfect complements utility function. A situation directly opposite to the case of perfect substitutes is perfect complements. These preferences would apply to goods that go together. For example, car and petrol, bread and jam, etc. They are used in a certain combination by a consumer, and maybe one without the other will have no use for the consumer. Only by choosing the goods together can utility be increased. This can be expressed in the mathematical form of the following utility function, that is uf, a function of xy, equal to minimum of alpha x, and beta y. Here alpha and beta are positive parameters, and the term minimum means that utility is given by the smaller of the two goods in the parenthesis. For example, the consumer requires 1 tablespoonful of jam represented by X with 2 slices of bread represented by Y. Then the utility function becomes UFXY equal to minimum 2X and Y. From the specified utility function, it is clear that 2 slices of bread, that is Y, with 1 tablespoon of jam, that is X, will provide 2 units of utility. Now, even if we increase the number of slices, but do not increase the number or quantity of jam, the utility attained remains the same at 2 units. The extra slice has no value without more jam because utility does not increase if only X is increased. If only both are doubled or increased proportionately, then only utility would increase. This shows the fixed proportional relationship between the two goods that must occur when the choices are made with respect to goods that are perfect complements. Now we will consider utility theories. There are two theories of utility which compare the satisfaction obtained from the consumption bundles by using these utility functions. One method gives importance to the numerical value of the utility, which is called cardinal utility, while the other method utilizes the numeric value to just rank the consumption bundles. It is called ordinal utility theory. It is called ordinal utility theory. First, we will consider theory of cardinal utility. There are some theories of utility that attach significance to the magnitude of utility. These are known as cardinal utility theories. In the theory of cardinal utility, the extent of the difference between the numerical value of the two bundles of goods is supposed to have some sort of significance. This concept was given by Alfred Marshall, where he mentioned that utility can be measured in terms of some unit. For example, if we have a cup of tea, then we are able to give an exact measure of satisfaction derived from that cup of tea. If we want to compare the utility derived from 1 cup of tea with that of utility derived from 1 cup of coffee, we use a utility function to get the value of utility for both. Suppose 1 cup of tea gives 20 units of utility to a consumer, while a cup of coffee gives 10 units of utility. It becomes clear that tea is preferred more than coffee. The numeric value by assigning a higher utility, besides telling the more preferred good, will also exactly tell us the intensity of preference. This reveals that a cup of tea gives twice as much utility as attained from a cup of coffee. For this, we require a standard unit of measurement in which utility of all goods can be measured. Money is the most appropriate measure which can possibly be used to measure and compare the utility derived from different bundles. But the value we place on a good depends on the value of the measurement unit, that is money. Its value has to be constant, and hence Marshall brought in an assumption of constant utility of money. This means a rupee means same to you, whether you are rich or poor. Hence, if you have money, the utility from 100th rupee should give same utility as first rupee, or for that matter, 10th rupee. It should not be the case that as you get richer, the value of extra rupee diminishes, or as the money left with you gets smaller and smaller, we start valuing it more, so that marginal utility of money keeps on increasing. Hence, there are certain assumptions on which this theory is based. A. The utility is cardinal, which means it can be measured quantitatively. B. The marginal utility of money is constant. Now, this method is not very appealing, as economists are of the view that to tell whether one consumption bundle or another will be chosen, we only have to know which is preferred, that is, which has the larger utility. Even if we try to understand how much larger the utility is, it does not add anything to the description of choice. The cardinality assumption is difficult to justify. Second is the theory of ordinal utility. Ordinal utility just ranks the consumption bundles on the basis of utility attained from each bundle. The magnitude of the utility function is only important insofar as it ranks the different consumption bundles. The size of the utility difference between any two consumption bundles does not matter. Because of this emphasis on ordering bundles of goods, this kind of utility is referred to as ordinal utility. In the above example of tea and coffee, tea gives utility equal to 20 units, whereas coffee gives utility equal to 10 units. This clearly shows that as tea is assigned a higher number, it gives more utility than coffee, and hence tea is preferred over coffee. We are not bothered about exactly how much more. Even if coffee gives utility equal to 19 units, then also tea is preferred over coffee. Hence, numerical value indicates only higher ranking and higher preferences, and no importance is attached to actual numerical differences in utility. Some important points to remember are as follows. First is more is better, also denoted as MIB, which also means monotonicity. It says if one bundle has more of a good than another and no less of any other goods, then it is a preferred bundle. For example, if a consumption bundle A consisting of X1, Y1 has the following combination of X1 equal to 3 and Y1 equal to 7, and another consumption bundle B of X2, Y2 has the following combination, that is X2 equal to 10, Y2 equal to 7, then B is preferred to A. This assumption fails if you assume that there is a satiation point, which is when mu is equal to 0 and mu is less than 0 thereafter. We have a figure which is showing this, known as figure 4, where we show more is better. Second point is non-uniqueness of utility measure. For two consumption bundles A and B, if a utility function UF gives a value UA equal to 10 and UB equal to 14, and another UF gives UA equal to 2000 and UB equal to 5 lakhs, in both cases the numbers imply that B is preferred to A. In technical terms, our notion of utility is defined only up to an order preserving or monotonic transformation. Any set of numbers that accurately reflects a person's preference ordering will do. Consequently, it makes no sense to ask how much more is B preferred than A, since that question has no unique answer. Third point is the assumption of ceteris paribus. The term utility refers to overall satisfaction, and this measure is clearly impacted by a variety of factors. A person's utility is influenced not only by his or her consumption of physical goods, but also by the psychological attitudes, peer group pressures, personal experiences, and the socio-economic and cultural environment. Therefore, a common procedure is to exclusively look at the choices among quantifiable options while holding constant the other things that affect behavior. This ceteris paribus, meaning thereby other things being equal, assumption is used throughout the analysis of utility maximizing choices so as to make the analysis of choices manageable. Fourth point is the three standard properties of reflexivity, completeness, and transitivity of preferences. These three properties that were discussed in previous modules are assumed to be fulfilled in order to have well-behaved preferences. Once we have these three assumptions about preferences, we can use them to find a way to draw a picture of people's preferences.
Now we will consider the difference between cardinal and ordinal utility. While the cardinal utility functions describe the extent to which one consumption bundle is preferred to another, ordinal utility functions only provide ranking to the consumption bundles. Unlike ordinal utility, cardinal utility concept attaches a numerical value to each basket which cannot be arbitrarily doubled or tripled without altering the differences between the values of various consumption bundles. Unfortunately, there is no way of telling whether a person gets twice as much satisfaction if the market value of the consumption bundle changes. Moreover, it is difficult to ascertain if one person gets twice as much satisfaction as the other person by consuming the same consumption bundle. Hence, a comparison between consumers is not possible. But here, we require just the comparison between different consumption bundles for a single consumer. For this understanding, ordinal utility theory is sufficient. The entire consumer theory tries to explain the consumer behavior based on a consumer's preferences. It is convenient to describe preferences graphically by using a construction known as the indifference curves. The concept will be discussed in great detail subsequently in next module. Let us summarize the discussion we have done so far. First, we have learned that utility is the satisfaction derived from consuming given goods in a particular period of time. We have also learned that marginal utility is the additional utility derived from consumption of one extra unit of a good. We have also discussed and tried to understand the law of diminishing marginal utility, which states that each additional unit of a good eventually gives less and less extra utility. Utility functions are a way to measure the utility attained from different consumption bundles. We have also seen that how there can be different types of utility functions. For example, it could be Cobb-Douglas utility function, it could be quasi-linear utility function, etc. There are two theories of utility which compare the satisfaction obtained from the consumption bundles by using these utility functions. These are cardinal utility theory and ordinal utility theory. Cardinal utility theory gives importance to numerical value of the utility, while ordinal utility theory utilizes the numerical value or numeric value to just rank the consumption bundles in order of preference.